Hello, everyone. Good morning. We are going to start with this webinar, focus on key actions to foster energy efficiency in energy-intensive industries. I'm going to share my screen just to show the agenda for the morning. This is the agenda we have prepared for today. We will start talking about Life Audit Plus project, which is the project where we have located this webinar. And then we will complete the webinar talking about the white certificates and choose projects that have some topics close related to the energy efficiency actions. Okay? So I'm not going to explain more about that because we are going to start the Life Audit Plus project coordinator, Luciano De Tomase, who is with us. He will welcome all you and he will explain a brief summary of what is Life Audit Plus project, which activities are we developing and which are the main results. So Luciano, the floor is yours.
Okay, thank you, Anna. Welcome everybody to this webinar organized by the Life Audit Plus project. Organized already a few webinars and they are all accessible from our Knowledge Hub. This is a new webinar that we are going to add. I'm going to give you a brief introduction about the Life Audit Plus project in terms of its objectives and activities that have been completed or are ongoing. So I'm going to share my screen and show the slides. So objectives and main activities, as I said. So the extended title of our project is Enhancing Energy Audits Schemes in Energy-Intensive Industries with Practical Approaches. The project started in October 2023 and is currently ending in September 2026. We are also in the process to request 3-month extension for the project, so it is very likely that the end will be December 2026. So one of the main objectives of the project was to establish, coordinate, and evaluate multi-stakeholder local groups at the EU level. These groups are called operational groups, and they act as a single intermediary for energy-intensive industries that are implementing energy efficiency measures following energy audits. So they are a kind of facilitator for the industries. These were set in Ireland, Poland, Spain, Castillon, and Galicia, and also examined the current gaps and needs to enhance the impact of energy audits conducted in energy-intensive industries. The project is basically developing a practical know-how for 2,000 value chain stakeholders, starting from existing technical and regulatory knowledge about implementation of energy efficiency measures and renewable energy generation. The project has developed and is delivering an integral consultancy service that is helping industries to reduce the carbon intensity of their industrial processes by, we believe, around 10% for a number of industries involved in the pilots. We also work with policymakers, industry associations, private companies, technology experts, bringing them together to foster the development of new standards. We have also started a pre-standardization document, which will be discussed in next presentation. The purpose of these activities to facilitate and boost investments of the energy-intensive industries in the implementation of the energy efficiency measures which are identified through energy audits. The Audit Plus project has developed an action plan which started with the analysis of the current business environment in the 4 industrial regions, Ireland, Castellón, Galicia, and Poland. In each of these regions, we have focused on different sectors. In particular, in Ireland, the focus is mainly on pharmaceutical, chemical, and healthcare. In Castellón, it is on the ceramic sector. In Galicia, it is the fishing, food processing industries, and in Poland is the food processing sector. The project has conducted an analysis called the PESTEL that considers political, economic, social, technical, legal, and environmental aspects that are acting as either barriers or drivers for energy efficiency improvement for the targeted sector in each industrial region. The action plan that we developed includes offering consulting service to 82 companies and supporting them through basically recommendations about energy efficiency measures and how to implement them. Also, we support them trying to improve the skills of the energy managers in the companies and reducing the energy intensity by around 10% on average. The actions undertaken by the project also include the creation of a white book of good practices, the creation of an energy manager profile. We offer an energy audit service, carry out training courses, and also have created a knowledge hub, which I will describe in the next slide. The expected results, so the results that the project is obtaining are related to improvements in policy and regulation, increasing knowledge of the energy-intensive companies, and supporting the development of better corporate energy strategies for the companies. So first of all, the project has gained some insights into the energy-intensive industries' perception of the efficiency levers of change. We have developed a proposal for standardizing the implementation of the measures after the energy audits. We have also defined the profile of the energy manager. The project has developed a knowledge hub, which is still under construction, but mostly done at this stage. Then has developed the energy audits good practice white book, training materials and webinars, has put together tools for calculating energy savings and return of investment, dissemination of successful stories for the companies involved in the pilots, and calculation of energy efficiency KPIs. And last one is the integral energy efficiency consultancy service for energy intensive industries. The Knowledge Hub is basically a dedicated section in our website, which is accessible from the link that you see there, and includes several sections about policy recommendation and practical know-how, including a general knowledge, training materials, and webinars. We are creating pages with the list of tools for calculating energy savings. Successful stories, I think, will be added shortly, and also KPIs. It's ongoing, so we have a section with some KPIs which is ongoing. The hub will be updated until the end of the project. So At this stage, we believe that the project will end in December. And everybody can contact the team and ask to be registered on the hub and access the information published in the hub. The consultancy service is actually a very comprehensive service that provides meaningful insights that help energy-intensive industries to validate their energy management strategies, the plans that they have for implementation of energy efficiency measures. It also helps to identify risks and opportunities, how to enhance energy performance, and help companies to make informed business decisions with higher confidence. The service comprises 7 sub-services that you see in the figure: technology assessment, cost-benefit analysis, engineering support, identification of public and private sources, matchmaking with service providers and technology providers, guidance for implementing energy audits plans, and corporate energy strategy. So these are different aspects the service can address. So this is all for the introduction. Thank you.
Thank you, Luciano, for this summary of the activities of the project we are carrying on. We will continue with 3 different presentations, one of each focus on different industrial sector that is addressed in Life Audit Plus project. We will start with the ceramic sector, based in Castellón in Spain, focus mainly on the ceramic tile manufacturing. Okay, my colleague Javier Bedri from ITC will present a summary of the most important, most relevant energy-saving actions that we can implement in the ceramic manufacturing. Javier, you can start.
Thank you, Ana. I'm going to share my screen. Okay, is everything okay? Can you see my screen? Okay, yes. Thank you. Well, I'm going to focus today, as Ana said, in the ceramic sector because it's our field of expertise within the project. And besides, we have created or we have organized an operational group within the project focused on the ceramic sector, on their main problems or energy efficiency actions that we can take in this sector. So first of all, I would like to talk a little bit about the current situation of the sector. This is the production process, the manufacturing process of pressed tiles, which is the most common process within the sector. And as you can see here in this slide, we have the production process from the raw materials to the final product. And there are 3 stages, which are the main energy consumers in the project. These stages or this equipment are the spray drying, the drying, and the firing. These are also the main sources of CO2 emissions in the ceramic process. The specific energy consumption for the spray drying is 476 kilowatts hour per ton of dry solid. And in drying, the specific energy consumption is 125 kilowatts hours per ton of dry solid, and in firing is a little bit higher. It's 793 kilowatts hour per ton of dry solid. So the main energy efficiency actions are going to focus on these 3 equipment. This is a general table or a general overview of the project. As you can see on this chart here, 10% of the energy consumed in the sector is electrical energy, and 90% of the thermal energy, of the energy consumed, is thermal energy. This energy is, this fuel is natural gas. So 90% of the thermal energy is due to natural gas consumption. Here we have some figures, some numbers of the sector. In 2025, the production was 423 million of square meters produced. Here we have some specific consumption of the sector, natural gas consumption, electricity consumption, and some specific emissions, 5 kilos of CO2 per square meter produced. And the energy bill in 2025 was 813 millions of euros, which represents approximately 17% of the total turnover of the sector, which is a high number. And once we have seen a little bit the current situation of the main numbers of the sector, second topic that I would like to cover is the analysis of the installation. And that's because if we want to apply energy efficiency measures, first of all, we have to know which is the current situation of our factory or of our company. For that, we have to identify the highest energy consuming equipment, and we have to know the consumption of every single equipment in our company, in our production process. And once we know this, once we know the energy consumption of the different equipment, we have to perform, or we have to analyze individually every single equipment. For this analysis, we have different options. For example, an energy balance, as you can see in this picture here. So this is a Sankey diagram with some inputs of energy and some outputs. And also we have the option to study or to modify the variables of the process, of the ceramic process. Some examples of variables in the ceramic process are, for example, the excess air in the burners, or the solids contents in the slip, or the gas composition, or the static pressure inside the kiln. We can modify these variables to achieve a better energy efficiency. So once we know what we have to do or what we have to analyze in our company or in our process to get a better energy efficiency, I'm going to explain which vertical energy efficiency measures we have in our sector, in the ceramic sector. First equipment I would like to bring to your attention is the spray dryer. The spray dryer is basically an equipment that uses hot gases to dry ceramic liquid known as slip. These hot gases dry the slip, and we get a dry powder. This dry powder is ready for the next part of the process, which is the pressing. So in this spray dryer, the main energy efficiency measures that we can apply to this equipment is the use of gases from a cogeneration turbine as drying gases, or the use of gases from a kiln cooling stack as drying gases. So this way we can reduce the natural gas consumption in this equipment. We can also implement an automatic control in this equipment, or we can optimize some process variables such as the drying gas temperature or the sleep temperature. We can also increase the solids content in the sleep to reduce the energy consumption. Next equipment is the tile dryer. The tile dryer is an equipment once the ceramic tile is formed. We need to reduce the humidity or the water in the tiles before going to the kiln, and this is the equipment that we use to reduce this humidity in the tiles. The main vertical measures that we can, energy efficiency measures that we can apply to this equipment is the use of residual heat from other processes, mainly the kiln, to use these hot gases in this tile dryer. We can also optimize some process variables such as the stack and the drying gas flow rates. We can also work on the heat distribution to avoid temperature gradients. And we can also work on the drying cycle, modifying the temperature and the humidity profile in a controlled way, because we don't want to modify another properties of the process, but we can work on these variables to get a better, or to achieve a better energy efficiency. Last equipment is the kiln. The kiln is the last part of the ceramic process. In this equipment, the tiles get or their final properties, or the final properties of the tile are given in this process. We can work on the optimization of some process variables of this equipment, such as the static pressure, the gas composition, the air excess in the burners, or we can also preheat the combustion air to reduce the natural gas consumption, or we can work on reduction of heat losses through walls and roof, improving the quality of the materials used for the insulation of the kiln. Or we can also use some hot gases, some residual hot gases of the kiln. We can use these gases in a per-kiln dryer, which would also reduce the natural gas consumption. Okay, once we have spoken a little bit about the main vertical energy efficiency measures on this equipment, I would like to show you this diagram. This diagram represents the actions that we can take first in the process. First of all, we have to work in the optimization of the process and to try to improve the energy efficiency as much as possible. And once we have done this, we have improved the energy efficiency as much as possible. We have also another options to decarbonize our project. We have options such as the electrification, the use of alternative fuels like green hydrogen or biofuels. We can also capture the CO2 that is emitted to the atmosphere. And we can also integrate some renewables, such as the photovoltaics or solar thermal. These are some of the decarbonization technologies that we have spoken in the previous slide. We can electrify some drying processes, or even the kiln, the firing process. But for decarbonization, obviously, this heat or this electricity has to come from a renewable source. We can also storage heat from renewable sources and use it in the process. And we can also use some alternative fuels like biomass or hydrogen, because, for example, the use of hydrogen reduces the CO2 emissions. If we use 100% hydrogen, for example, replacing the natural gas, we could reduce our CO2 emissions 100%. But we have to work on these technologies. We have to still develop a little bit these technologies to make them feasible or possible for the ceramic sector. Another option of decarbonization are the heat pumps also, which improve the temperature of a residual heat source. We can improve or increase this temperature to reuse it again in the sector, in the process, sorry. And this measure also increases the energy efficiency. All these technologies can be found in a guide that we have developed, that we have published, and can be found in our webpage. Here you have the link to download this guide. This is free, so you can access our webpage and download this guide. You will find information about these technologies and also energy efficiency measures applicable to the ceramic sector. So you can download it for free. It's in this guide is in Spanish. I forgot to mention that. This guide is in Spanish, but it also has an executive summary in English. So yeah, you can check it in our webpage. And last slide. We have a presentation later that will talk about white certificates and energy certificates, but just a brief slide that I would like to bring to your attention. We have some possibilities of get white certificates by applying energy efficiency measures. Here in industry, we have some, in Spain, we have some standardized measures and some singular measures. The standardized measures are published by the ministry, and there are some technical sheets that talk about these standardized measures. Some of them are the waste heat recovery, for example, or the thermal insulation of pipes, or the implementation of variable frequency drives, etc. These are some technical measures that, as I said, are standardized and have technical sheets, but in some cases, it's not possible to apply a standardized measure. In these cases, we have to work on a singular measure. Singular measure needs verification. That means that an external company has to verify that the measure applied saves energy. And for example, we have some singular measures here, some 3 singular measures applied to the ceramic sector. These are real cases. First singular action is the installation of an air-to-air heat exchanger in the kiln exhaust to preheat the combustion air. Is a singular measure applied to the sector. Another singular action is the replacement of the kiln refractory with new materials. And the last singular action applied to the sector is the installation of modulating burners with proportional O2 control and variable frequency drives on combustion air fans. When these measures are applied, if the verification is correct, we get some white certificates that can be exchanged for an economical compensation for the company. And this is the last slide. I would like you to invite you to join or to follow us or to check our webpage, our web pages in Spanish and in English. And I would like you to follow us, to invite you to follow us on our social media, LinkedIn and X. Here you have the names, so you can check it and follow us and join us. And thank you very much for your time. And Anna, that's all from my side.
Okay, thank you, Javier, for this short but intense presentation regarding the options of energy savings in the ceramic process. Now let's move on to our next speaker, which is Buse Turna. Buse works in Lawler Sustainability, which is an Irish decarbonization consultancy. Her presentation is focused on the pharmaceutical industry. And now, Buse, let's move to your presentation. You can share your screen. Thank you.
Thanks, Anna. I'm going to share my screen for now.
Sorry, I think it's my fault because I'm still sharing my screen. Give me 1 second.
Okay.
Okay. Now we can see your screen, Buse.
Yeah, thanks, Javier. Thanks so much. Okay. Okay, can you see my screen clearly, right?
Yes, perfectly.
Okay. Perfect. Thanks, everyone. I'm Buse Turna from Lawler Sustainability in Ireland. As part of the Audit Plus project, Lawler Sustainability carried out energy audits across a number of pharmaceutical sites in Ireland. Based on the findings from these audits, today I will share some key insight into energy efficiency in the pharmaceutical sector. Okay. Yeah. Energy efficiency starts with understanding where the energy goes in all industries, not only pharmaceutical side. In pharmaceutical facilities, steam and process heat are the often major energy users, followed by systems such as HVAC, AHU units, chilled water system, and the compressed air side. Many of these systems also operate 24/7, which can create a significant energy base load. So the key message is simple here. First, identify the measured energy users, then use real data to prioritize the right projects. The next step is to optimize existing utility systems before investing in major capital projects. In pharma sites, we often see the opportunities in HVAC, HU units, steam, compressed air site, chilled water systems. Many improvements can come from relatively simple actions such as better HVAC, HU schedules, set points schedules, leak reduction, compressed air leak reduction, and system controls. So the key message is optimize first, then electrify the remaining demand. This helps avoid oversizing future equipment. Okay. Oops, sorry. We start with the current carbon footprint that you seen here. This is an only example from our audit report results. Then first reduce the unnecessary demand through controls and set points, followed by reducing steam and air losses. After that, we recover available waste heat and electrify the remaining useful heat demand. Finally, renewable electricity are sized against the already optimized load. For example, solar PV panel, if possible, wind turbine, something like that. The key point is that every step reduces the size of the next projects. For example, our current thermal carbon footprint, 100%. It's from 100% to 92%, 92% to 75%, and the final load is 25% based on this carbon footprint. When we think about the heat recovery in pharma, water-to-water heat pumps often comes to mind first, because these sites frequently have simultaneous heating and cooling demands. Vast heats from the chillers or other utility system can be upgraded and reused for low pressure hot water, CIP hot water, or AHU coils. The key is to match the right heat source with the right heat sink and check that the loads occur at the same time. You can see the process here, the basic process for the recovery heat. The priority is to start with the low-cost and no-cost measures first, such as compressed air leaks, AHU schedules, and steam traps. Then we move to CAPEX, energy efficiency projects, followed by electrification of heat, such as heat pumps, and finally renewables like solar PV. The key point is to optimize demand first, then decarbonize the remaining load. It was my last slide. I would like to answer if you have any question or any specific question regarding the pharmaceutical sites or any other industrial sites. Yeah, thank you.
Thank you, Buse. We will have a dedicated slot of time for questions and answers at the end of the webinar. But if someone wants to ask a question, can raise the hand.
I'd like to give a space for some questions. I'm happy to answer these questions if you have it.
Okay, thank you. Thank you very much. Okay, now we are going to join Sandre Costas and Tomasz Kulakowski. Both will show us some energy-saving measures that could be applied in the food processing industry. Sandre is working in a research center in ITG, located in Galicia, in Spain, and Tomasz is working in the Polish Energy Agency, NAPE. Both are partners of Live Audit Project. And now, okay, the floor is yours. Sandre, you can start sharing your screen.
Tomasz, do you prefer to start or I could start? I don't know. I start, okay.
Yes.
Okay, no problem. I'm gonna share this view. Okay, I don't know if you could see the presentation.
Yes, Sandre, it's fine.
Okay, I'm gonna put in. Okay, so first of all, thank you, Anna, and thank you, Javier, for the organization of this webinar, and obviously to all of the rest of the people who are listening for joining this webinar. First of all, I want to introduce a little bit myself. I'm Sandre Costas from ITG, from Galicia, as Anna said before. I specialize in energy. I'm an energy engineer, and I'm specialized in projects about biomass and biogas and efficiency in that sector. So today I'm going to talk about energy efficiency measures in the food sector. I want to start talking about the food sector because there are a lot of types of companies, a lot of types of needs, but the the objective, it's not what do you produce, it's what you need to produce that. For example, if you are a bake industry, your main demand, it's heat demand. But if you are, for example, meat cutting, you will have demand of cold and electricity too. And there's something particular in the food sector, that there are principally two types of industry: the continuous industry and the seasonal industry. This, for example, is a winery. That the winery, the principal activity is during August to October, that have the main energy demand. So I'm not going to talk about different types of industry. I'm going to talk more about what they need, what that industry needs. So Javier explained very well the process from audition. So I'm not gonna talk a lot about that. Maybe in the final part of this course, but I'm gonna talk especially about the applicable measures and some example applied to the food sector. The first applicable measure is about heat. The most obviously part could be the heat recovery. You know, in food industry, you could recover heat from combustion gases, from hot water exits, that you could implement plate heat exchangers to preheat that water in the start of the process. Or you could also, for example, in some compressors, in that electrical equipment, put heat recovery that you obtain from the heat dissipation. They also talk about the replacement of fossil generation with heat pumps that have a high performance. You could also do, and it's a very important part, thermography of heat circuits and insulation improvement, because it gives you a lot of information about how is that installation and how could you improve that part. You also optimize and the operating parameters to know better how is your system, and you could implement some energy storage systems or energy recovery from waste. No, that especially I'm specialized in. For example, no, I talked before about the winery. No, in the winery, you have some biomass that is ligated to the process from the production of wine, and you could explore the introduction of a biomass boiler to reduce the heat demand of fossil fuels. In the right, I put an example. This is an example of a big food industry that had a biogas generator, and when the rest of the heat demand, it was supplied with diesel. And if you integrate a heat pump to the heat mix, you could reduce about 16% the thermal demand reduction, and for the reduce of use of diesel, you reduce about 5 tons of CO2 emitted. Another similar measures are the applied to the coal lines. This is also with the replacement. The measures, are the replacement of conventional coal plants with reversible heat pumps that could also give you hot and cold energy. Also, the thermography of heat circuits and insulation improvements, the programming and optimization of operating parameters, and this is more difficult, but you could also implement storage systems. In the right, you see a very visual example. No, this was a detection of losses in a cooling system that it crosses with a hot pipe. In the bottom, you see a hot pipe, and in the middle, the cold system. You see that in 20 centimeters, there's a line that is 0 degrees, and another line that is nearly to 50 degrees. So if you implement is you upgrade the insulation improvements. You could reduce the operating set points, have lower cooling demand, and significant savings with a low implementation cost. That is very important in this part. And for last, you could do also some electrical measures. I'm gonna divide this in two parts: the active measures and the passive measures. The active measures is that Javier talked before, that it was the replacement with high efficiency motors, because when you when we go to some industries, we saw that if that motor works, don't touch it. But it's really important to replace this equipment, because they have a lot of hours of work, and the payback it's a very positive payback for this part. You could also install frequency drivers, the optimization also of the compressed air systems. For example, another active measures would be the installing of renewable generation, but photovoltaic, or the installation of capacitor banks to reduce the reactive power. In the right, there's another example. No, it was an example of the of a sector that have a lot of grinders. Before the project, the sector starts the grinders when they start to work at 8 o'clock. So if you program that start, they had also a photovoltaic plant. So what we do is scheduling the gradual startups to fix the solar photovoltaic production to the demand. So by just little adjustment, they could reduce significantly the external energy consumption. And another, not as important normally from the industry, but for me, for example, is the most important, are the passive measures. Because if you have a good passive measures, you have a lot of very important information from that plant. For example, these passive measures are the energy monitoring and digitalization, the automation and control of energy process, and the scheduling and energy tracking from performance of indicators. This was, for example, an energy baseline from an industry that they had the actual consume of demand of energy, and from by baseline energy baseline, they could identify the energy behavior patterns. They could do a consumption forecasting, and they had energy performance indication that actuate that preventive maintenance. And for last, in the first part of my presentation, I talked about the difference between continuous and seasonal industry. The mainly difference are in the continuous industry, there are a lot of high annual utilization. They work all year, and when you are talking about to replace equipment and from the payback of that equipment, there are a good indication. It's a good indication to pay that investment. And in the seasonal, that this is a very difficult part. Another part, as the energy charge dominates the cost structure over the power charge, and in the seasonal, it's used to be in the opposite way, that the power change weights disproportionately in the cost or compared to the energy charge. Mainly for last, the load curve shows that moderate daily weekly variability, but no market seasonal discontinuity. This means that every year the continuous industry it's very stable and very linear. But in the seasonal campaign it's the opposite. And only for my end of this presentation, I want to remark that the capex of efficiency equipment parallelly pays with the relevant service life, that it operates some weeks for year, and this is very difficult. And thank you for listening me. And I'm from ITG, so I wait from the question to the final of the webinar as Seyana. So thank you very much to all.
Thank you, Sandre. Now we switch to Tomasz Kulakowski, who will continue explaining us interesting issues about the food industry.
Hello, just let me know if you see the presentation.
Yes.
Okay, so as it was mentioned, I represent NAPE, which is a National Agency for Energy Conservation in Poland. And our input to Audit Plus project was assisting food and beverage industry or food processing industry in Poland in improving their energy efficiency. So we were working together with factories from group of Kolian, which they this group focus on production of sweets, some sweet beverages, ice cream, and assortment like that. We assisted 3 plants, which are separate companies from this group. Each of the plant focuses on different production profile. These were plants in Bydgoszcz, Opatówek, and in Kalisz. In Bydgoszcz, they focus on small assortment like cookies or jelly bears or some nuts and raisins in chocolate, stuff like this. In Kalisz, they produce only waffles, and in Opatówek, they produce exclusively beverage. And after discussion with their representatives, for them, the key challenge in upcoming time is implementation of the European directive, which will force all of their plants to introduce ISO 50001 energy management standard, because each of the plants are about, well, this is a little bit problematic because we know what European directive says, and they expect that this obligation will apply to them. However, we still wait for Polish implementation of this law. We expect it to be the same as directive, but we still are not 100% sure if each of the plant will be under this regulation. However, they are already trying to prepare for the next year change in law, because we are waiting that somewhere in the end of this year this implementation will take place. So before that, in Poland, but I assume all across the Europe, each company that was above some threshold of energy consumption was obliged to make energy audit. And each of their plants had energy audit, but also Kolian as a group made step of gap analysis, what they need to do to adjust their energy management system, which they already had some internal procedures and standards developed how to manage energy, how to report it, because they also report energy consumption and some CO2 emission, let's say. So basing on this gap analysis, we set a scope what we can assist them in within this Audit Plus project. So we started from energy policy for whole group. Of course, this policy applies to whole group, and this is something that they have to announce and they have to introduce. However, we assisted them in making this policy compliant with ISO 50001 requirements. We also we took the latest energy audits and checked what is missing to fulfill the ISO 50001 energy review requirements. And these 3 tables are for 3 plants. And as you probably can guess, The green boxes means that the requirement is fulfilled, and orange is that it's partially fulfilled. Red, it means that it's completely missing in the energy audit. So we developed whole, let's say, methodology of together with them. We gave them document that is, I don't know, probably like 15 pages long of how the energy audit should be, energy review should be performed within each plant. And this is important because this methodology is also required by the ISO 50001, that it has to be defined and documented so that each following energy review will give consistent results and can be compared one to another, no matter who is performing this energy review. And within this methodology, we also established some methodology of how to define significant energy uses and how to define key performance indicators and energy baseline for each of the significant energy uses. And we also, let's say, calculated or defined these KPIs and energy baselines for each of the significant energy uses we chose together with them. Of course, they can define more. However, we advise them that at the beginning, it's better to monitor fewer KPIs and then expand it together with expansion of energy management system. Now, here, if the baseline is red, it means that it is applicable to heat consumption, which in their plants is generated partially through gas boilers, partially through combined heat and power, and blue is for electricity. And they also have, as I said, combined production of heat and power, but also they have photovoltaic plant in one of their factories. So we gave them this as a Excel sheet so that they can fill in data in monthly time step, and each of the KPIs include parameters like weather, of course, because despite the fact that they consume vast majority of energy for the production processes, not for heating just of the office buildings or cooling of the office buildings, performance of these processes is also dependent on weather outside. But also another factor are volumes of products. Now, this was challenging because they have varied assortment. It's not that they produce only one product, and this product also is different in each month. Sometimes they produce more of the, let's say, cookies, sometimes more of the ice cream, sometimes more of the waffles. So we decided that instead of using product as the variable for our functions, we defined what are the key sources, raw materials that I use, like flour, like butter, chocolate, things like that. There are 5 different types which are defined in each of the companies separately, because as you can imagine, they don't use much of the flour in beverage factory. There they use mostly some kind of sweeteners and juices because they add juice, fruit juice to their products. In a factory where they use where they produce only waffles, they use mostly flour and water, sugar, of course. And with cookies, it's mostly raw chocolate and some nuts. So for each of these plants, we define different functions, different performance indicators. We define this baseline, and they are ready to monitor it each month. So now we're working on implementation of procedure for operational planning, because this is something that requires a lot of communication, not only with the representative who was working with us on the energy data, because this is also working with management department. management department who is approving some costs, because according to ISO 50001, all the design and all the purchases has to be done according to some policy, or let's say procedures that are approved within the company, or actually in this case it would be within whole group, because they would have to implement ISO 50001 to whole group. Of course, if Polish regulations will follow directly the European directive in this matter. So we proposed some procedures for this design and purchases, and now they are working internally to check if, because they have to assign who will be responsible for what, and this is something that we cannot do without them. So they are working internally on assigning some positions, some people who will be responsible for these steps within each company, because despite the procedure has to be global, this company has to, or group has to assign particular positions who will be responsible within each factory. So that will be it. If there are any questions, I'm happy to answer them, or try to answer them, but that would be it from my side.
Thank you very much, Thomas. Okay, and now we are going to focus on another activity carried out within the framework of Life Audit Plus project. We have promoted a CEN Workshop Agreement through the Spanish Association for Standardization. Teresa Sanchez from the Spanish Association for Standardization will explain us much better what is this workshop agreement and in which stage of the process we are right now. Okay, Teresa, thank you for coming and joining us, and you can start.
Okay, thank you. I'll share my screen. I think. Okay. Are you seeing my presentation in presentation mode?
No, not yet.
Mm-hmm. Now?
Now, yes.
It's okay. Okay, well, thank you. Good morning, and thank you to Audit Plus for inviting me to this webinar. As Ana said, I'm Teresa Sanchez, and I'm representative from UNE. I'm project manager at UNE. UNE is a non-profit association, and it has been legally designated as the Spanish standardization body since 1986. We are in Madrid, in this building you see in the photo. We are around 90 persons working here, and our main activity is the production of standards. We also take part in international cooperation projects, and we have also an extensive experience in taking part in research and development projects like Audit Plus. We have taken part in more than 130 projects linking standardization and research. We are also members of the international standardization organizations. So we not only produce Spanish standards, but we also take part in the production of European and international standards. We are members of CEN, the European Committee of Standardization, and of ISO, which you probably know more, the International Standards Organization. So today I will talk a little bit about standardization, which is probably a topic you are not so familiar. Then about one standardization tool called CEN Workshop Agreement. I will talk a little bit about the achievement of Audit Plus on this topic, and I will end with the benefits of including standardization in research and development projects. So, what is standardization? Very briefly, standardization is the creation of voluntary specifications by a group of experts These specifications or documents are voluntary, but are in most of the cases very highly accepted and widely recognized in the market. They are based in the consensus, and they have to be done, these documents, in the framework of standardization organizations. Why is it interesting to include standardization in research and development projects? On the one side, because you can use the network of experts in the standardization world as a dissemination channel, and also because translating your results into standards facilitates the utilization by the market of the developed solutions. And also you will have, by producing a standard, a document that will be alive after the project life, so the long-term impact of the project will be increased. And also I want to highlight that Horizon Europe recognized the importance of including standardization in research and development projects. And in the project assessment, there's a specific indicator in every project related to standardization. So, as I said, standard document standards or other type of standardization documents have to be developed within standardization organizations. And which are the standardization organizations that can produce standards? Well, at international level, we have ISO, which is the most famous one, and also IEC for electrical issues, and E2 for telecommunication topics. At European level, we have CEN, CENELEC for electrical topics, and ETSI for telecommunications. And then also in every country, there's a national standards body, as we are in Spain, UNE, but we have also DIN in Germany, AFNOR is in France, UNITALY, etc. So, and these organizations can produce different types of documents. The most famous or common ones are the standards. You have ISO standards like the ISO 50001 you mentioned in the previous presentation, or EN standards for Europe, etc. But there are also technical specifications, which are another type of standard where you need less consensus and the duration is more limited. Then you also have technical reports, which are not standardization documents, but are produced by the standards organizations, are informative documents. And you have also another type of standard of standard deliverable, which are the workshop agreements. These documents are very interesting for research and development projects, and I will explain why. The first three types of standards are developed by groups of experts that are on a regular basis working with the standardization organizations, are like registered there and working all the time on different topics. And the documents have to be approved by the national delegations. Each country votes, and you have to reach a consensus by your countries. And the process to develop these kind of documents is long because you need a lot of debate and consensus by the countries and so on. So it takes more than 2 years in most of the cases. But in the case of the workshop agreements, they are developed by specific working groups created ad hoc for these documents by independent experts. So here, it is not the national delegations that vote to approve the document, but the individual experts that build the working group, reach a consensus, vote, and the document can be published. So the development process is much faster. You can develop a workshop agreement in approximately a year, and is also more flexible and easy to start. So the production of workshop agreement standards is very well fitted for research and innovation projects. So a little more detail of what is a CEN workshop agreement. The CEN workshop agreements are these workshop agreements developed at European level in the framework of CEN, the European Committee for Standardization, and they are standards with a lower level of consensus because it's not the countries who vote, but the international experts, but they are standardization documents and are included in the catalog of CEN, of the European Committee of Standards. And you finally have a standard like this example I put here. What kind of content can you include in such a CWA standard? You can include a lot of types of content like terminology or a methodology or a set of KPIs of test methods, etc. You have to bear in mind that the information you put in this standard will be public, so you cannot include confidential information. And also, as this is going to be a standard, the information should be reusable and replicable by other organizations outside the project. It cannot be like a project deliverable only fitted for the project. It had to be something more general and more reusable. And you can think also that it can be reusable in other sectors, different from the one you are dealing with in the project. The process to develop a CWA standard, it's quite easy, and you will always be guided by the national standards body. The first, indeed, the first step you have to cover is to contact a standardization body in your country or in other country to guide you throughout the process and to help you. And so once you have identified the need in your project and you have detected some research output in your project that would be part of a standard that has a standardization potential, you contact your standards body and you will establish a working group that is called CEN Workshop. That's why the document is called CEN Workshop Agreement, because it's the agreement of a CEN Workshop, of a working group called CEN Workshop. You create the group, this is made public in the CEN website so that any interested stakeholder outside the project can also engage with the working group and contribute to the development of the document and contribute to the working group. So once you have the working group and the stakeholders engaged, you start drafting the document. The work is done mostly online, so you don't need to meet or to travel to meet. You work online and you comment the document online. And once the working group has agreed on a document, again, it is made public to the world through CEN website. Then publish the final document you have agreed in its website so that everyone in the world can read it and make a comment on the document. This is to assure that the document that is going to be a part of the CEN catalog and considered as a standard has made in an open way and based on the consensus of the sector. And once you have received these comments, manage them and include them or not with a justification, and you have your final document, it is published by CEN as a CWA standard. As I've said, the typical timeline for developing that is more or less 12 months. So the Life Audit Plus project is in the process of developing a CWA. They have detected that they have generated some outputs that had a high potential to be standardized and used outside the project by other companies. And so they have reached to us, to UNE, and have started the process. The main objective of this, why they consider this CEN workshop is interesting, is because they have detected the absence of guidelines to address the post-energy audit activities. And so they consider they could cover this gap. So the main goal, the topic of the CWI generated by Audit Plus is new recommendations for monitoring and follow-up of energy efficiency measures implementation. And the main goals is to establish guidelines and best practices for the implementation of energy efficiency measures in energy-intensive industries identified after energy audits, and provide a framework to improve the energy efficiency after energy audits in energy-intensive industries. It is applicable to any sector, but in particular to energy-intensive industries. And the expected benefits by publishing this standard is to help industries to implement energy-saving measures, and by that increase the energy efficiency in these industries. Also to define or create a profile related to that, a work profile, and increase energy the employment dedicated to energy efficiency, and also to contribute to achieve the EU goals on energy efficiency objectives of GHG emissions reduction and energy save, etc. Regarding the process of developing this TWA, we have started in last April, I think, and we are now in the phase of the open public commenting. So now at this moment, the final proposal for the TWA standard is public on CEN website, and you can access it and comment on the document. I think it's open till 17th of July. In the link you see here, you can access the open commenting consultation. And well, to end with my presentation as a recap, why it's interesting to combine research and development projects with standardization, because well, we consider that this is a way to transform knowledge generated into practical guidance, to engage more stakeholders in the work developing the project. It increases also the project visibility. It makes faster the adoption by the industry of project outputs. You will have a legacy after the project, a document published that will exist after the life of the project. And these TWA standards can be the stepping stone to a future EN standard. It can be the origin, and then maybe a technical committee, a group of experts working at CEN can take the document and transform it to a EN standard. And that's all from my side regarding standardization. So thank you very much for attending.
Thank you, Teresa, for your insights regarding this topic, which is quite new, I think, for all of us. So it has been it's been a real interesting process. The development of this workshop. It's really nice. Okay, so now I have to tell you that we are some minutes behind the schedule, but I think we can manage with it, because at the end of the webinar we had some time for questions and answers and an interactive quiz, which is really interesting, and I think we will save some minutes on these two parts. Okay, so let's move to the next speaker, which is Rafael Mirat. He will explain what are white certificates, which will turn energy savings into measurable impact, measurable and economic impact. So it's a really interesting issue to manage in the companies, to get some revenues from energy for the after the implementing of energy saving issues. Okay, measures. Okay, so Rafael, Teresa, are you ready? Yes.
Yeah,
you are
I'm
here.
ready. Can you please confirm, Anna, if you are seeing my screen?
Yes, this is your screen. Okay.
Okay, perfect. Thank you. So thank you very much, Anna. Thanks everyone for the participation. Really interesting topics. I will be focused on some topics that, for example, Javier previously mentioned, which are the white certificates schemes in Europe and most importantly in Spain, which is where we work. Just for you to have a bit of background on who I am and where our expertise come from. I come from a company called Kairos, which I founded a year ago. And what we do is we work as a technical office and commercial office for companies in Spain that are both trying to save energy and get fundings to do so, and also for companies that are obliged to buy these energy savings that then will be discussed as how they turn into CAEs and comply with the target obligations with the European Union for energy savings on a yearly basis. So I guess this is for people in Spain, this might be something that is well known for areas such as Javier's and Sanders in food or in industrial processes, but for you in the European Union, different countries, you will have heard of this maybe with different names depending on the country you're working on. So to have a quick overview on what we will discuss, we will be discussing what are the white certificates on a general basis. Then I introduce you to the CAEs, which is our use case in Spain. Then I will speak a little bit on the impact that this system has had in the Spanish energy environment over the last 3 years, almost 4 years now in 2027. Some case studies, so you can have a glimpse on how this can possibly impact on different projects. And then at the end, of course, we will move forward to questions and our contact details, which will be done after all of the other presenters are done with their part. So I guess most of us here in this meeting have been struggling to get subsidies, to get public funds to do projects on energy efficiency that are very intensive on CapEx. And this is what the white certificates come to solve. Basically, white certificates are schemes that are under the European Union directives on energy matters. I will share with you later which directives are these in case you have interest in reading through those. And basically, what they do is the European Union directive aims for the different countries to set a target on energy savings to be achieved on a yearly basis, generally until 2030. And then each member state apply these targets and decide how they meet with these targets. It can be done through funds directly obtained from different parties in the ecosystem of the energy sector, which can be energy suppliers or distributors, for them to put some money on a pot from which then subsidies are obtained, or they do what we call the white certificate scheme, and they turn around the ways we work, so that companies that are obliged to put money into this pot for funds, rather than putting the money in this bucket and then this bucket being allocated to projects, they fund projects directly by issuing white certificates. So basically, as we to have a timeline of how this works, governments set energy efficiency targets. Companies then, of course, companies or any particular person, for example, if you change your combustion car for an electrical car, it also counts as energy efficiency. Then companies and people, they do the project to save energy, so they implement energy efficiency measures. The savings obtained through these measures are then calculated, defined, and verified. So, for example, the previous part of the presentation we had from UNE Ainor. Ainor in Spain, for example, is one of the companies that can actually calculate and make sure and certify that these savings exist. Then, once these savings are calculated and they are certified, there is a white certificate issued, and then this white certificate can be applied with two purposes. One, to meet the targets of the country, and then so for them to be cancelled against the national registry, so these energy savings are accounted for. Or if the company that obtains these certificates have an excess, they can be sold in a secondary market. So we have a market incentive here, and we move from a public way of funding energy efficiency projects to a private way of funding these projects, which is usually much faster and much more efficient. And on the right-hand side of the presentation, you have some countries in the European Union which have have had this kind of scheme. You can see in orange the United Kingdom, Poland, and Italy, which used to have or still have, but it's a very low-key and permanent market, these kind of incentives. Then you have in blue France and Spain, which are up to today the most mature markets, as actually Spain market was created out of French market, because French market is very mature and it's been a great success story. And then you have in green Ireland and Hungary, because as of last year, and I think also this year in the case of Ireland, they have started having this white certificate scheme in place. So it's good to see that most of the countries in the European Union, or it's a trend for these countries to be adopting these methods of working. So let's deep dive into Spain. I'm going to introduce you to the CAEs. CAEs stand for Certificado de Ahorro Energético, which is energy saving certificate as it stands. And Spain in 2014, they took the directive of the European Union and they defined what's called the FNEE, which it translates for National Fund on Energy Efficiency. And coming back to what I was explaining before, obligated parties in Spain, which are energy suppliers for both electricity, petrol, and gas, depending on how much energy they sold, they had to put some money into a fund for subsidies then to be taken away or drawn from this fund. So up until 2023, when the white certificate scheme in Spain started, they had one option, which was, okay, so there's a regulator in Spain that will define how much money you have to put into this fund per megawatt energy that you have sold, and which is your obligation to supply these funds. So they had to put a certain amount of money per megawatt hour they sold 2 years prior, which is the way it's calculated. From this pot of money, subsidies are created and this money is drawn to fund energy efficiency projects, and then we comply with European obligation and targets. What's the problem with this? That's as I was explaining before, subsidies and aids take time to allocate and to be granted. So Spain switched into the white certificate scheme as it was already in France, and we turned the ways around. Through these white certificates, first, the different energy efficiency projects are fulfilled, are completed, or they're planned taking into account the white certificates. These savings are certified by a third party and then also by a public entity. Once these savings are certified, obligated parties purchase them at a lower price than the regulator would force them to put money into the fund, so that they both comply with the obligations at a cheaper price, and they help funding and boosting the different energy efficiency projects across the land. You can see some numbers below, which is 8% and 92%. That stands for this year how the fund has to be completed. 8% of the obligations have to be provided by the obligated parties at 198 euro megawatt, which is defined by the regulator, but they can buy the white certificates at any cheaper price so that they have a most efficient way to comply with their obligations. But how does this work? How do we translate this to real life scenarios, as for example, heat pumps and heat firing that Javier was mentioning before in his presentation? Well, it's a very simple workflow, and it's important to highlight that all the parties must be aligned because each one plays a key role. Let's start from the beginning. First, let's assume that the energy efficiency project has already been performed, so we have already something that's been created. We're already saving energy in the industry in Spain. The owner of the savings, which is the company that has made the project, then will be in charge of looking for a party that will buy these savings, which will be an obligated party, energy retailer, for example, or what's called a delegated party, which is a company that has the rights to buy savings and create the CAEs for them to be sold to obligated parties and incentivize and move the market in Spain, rather than only having the obligated parties being able to buy, issue, liquid, cancel, and transfer. Once the property of these savings is transferred over these subjects, they apply for independent verification. For example, AENOR. They will hire AENOR or any other certifier to say, okay, this project exists, and according to the type of project, as also Javier was mentioning before, standard or singular, they will follow a workflow to identify, okay, we have all this documentation, the calculations are correct, so here are your CAEs. Once the independent verifier approves the issuance of the CAEs, this goes to the subject that has applied for it, and he has to submit again this documentation plus the certification of the private certifier to the public entities. So, for example, I am in Madrid, so I will send this information to the Comunidad of Madrid, and then Madrid will be in charge of rechecking all the information. Once this is done, the CAEs are created, and if they are applied for by a delegated party, these CAEs will be sold to an obligated party who will buy at a price lower than the obligation that we saw before, the 198 euros megawatt, so they comply with their obligations at a cheaper price. And then, of course, the delegated party will have a profit on the management of the CAEs. But at this moment, it's very important, the original owner, the person or company that performed the energy efficiency project, is paid in fully at the agreed price. It's a free market, so there will be an agreement of price between the owner and the subject that we will be issuing the CAEs. Finally, once the CAEs are issued, as I said, then it's up to the subject to do with them as they please. There is a 3-year validity from the date of the end of the project until the date that the CAE must be used. So it can be freely traded among subjects, but after 3 years, it has to be used to comply with obligation for any given year by the subject that purchased the CAEs in the first place. Now let's speak a little bit about impact. I'm not going to go into all of the numbers here, but just for you to have a glimpse on how this system is impacting the Spanish energy landscape. You can see on the left-hand side of the table different years since 2023, where this market started. And then you can see on the second column the target of savings for the country. You can see that we moved from 2.3 giga to tera to 11 tera in 2028. So, and this is still forecasted, but this year, 2026, we have 9.4 tera, which is a huge amount of energy to be saved into and through the CAEs. And then for the rest of the table, you will get a presentation later, but also for you to see, it's how much of these funds have to be provided at a fixed price, which is the fourth column. We moved from a 60% voluntary CAE submission to a mandatory submission at the price of the obligation to a potential 5% in 2028. So the market is moving towards a completely CAE market rather than being split between obligations and CAEs. And also, so for you to see some gross numbers, by the end of these years, 17.4 terawatt hour of savings should have been achieved in Spain. And so far, as of yesterday, 7.18 tera have been issued in CAEs out of 9.9 tera that have been requested. 1.57 have been denied because some documentation wasn't correct. And then the remainder, there are some numbers floating around. It's what we call desistimiento, which is when you're applying for a CAE and then you cannot provide all the information, so it stays there and they are not quantified. So also, if you go into the Spanish website for the CAEs, you will see that the average price ranges between 115 euro megawatt and 140 euro megawatt for the savings. So this is the first price to be agreed between the owners and the subjects. So if we take an average in that bracket, we can see that close to 915 million euros have already been saved and worth of energy efficiency projects. So all the energy that we've seen so far, all of the savings have been sold for an average total amount of 950 million euro, which is a great amount, and it's a great way of boosting the efficiency market in Spain. And finally, to conclude, I wanted to bring you some examples that we've been working in Kairos and we have been doing with some clients. This is all with end users. So these are companies that we have helped getting money and getting funds for the projects. And I brought one of each different area we work in. On the left-hand side, you can see that we saved 2.02 megawatts, so 2 gigawatt around of energy savings by applying speed modulation on heat pumps, motors, and compressors. And through the CAEs, this company got back 63% of the investment. On the residential sector, we're also working with housing and with buildings where people live. So this is a building in the south of Madrid. And what they did is they improved the thermal envelope of the whole building. They saved 137 megawatt hour a year, which was also split across all the different neighbors. And this amount covered 17% of the investment they made. On the tertiary sector, we also helped a company update the ventilation system, saving 27% of the budget. And last but not least, this also applies to transport. As I was saying before, if you move from a combustion engine vehicle to an electric vehicle, you will also be getting CAEs. So in this case, there was close to 230 megawatt hours saved by switching 3 combustion engine trucks for 3 electrical trucks, and this covered for 15% of each truck. Well, this is all I wanted to share with you. I wanted to focus more on the market than on the company, but also for you to know, we are Kairos. We manage the whole life cycle of CAEs, as you've seen, from identification to calculation, certification, and then all the market aspects of it across subjects. So if you have any question, both for the end of the presentation or outside of the presentation, you have here my contacts. I'll be happy to connect. Thank you very much.
Thank you, Rafael, for your presentation and for showing us how is working, how is going on the market of white certificates in Spain. Now we are going to move to the last part of our webinar. There will be a presentation of 2 different projects. The first one is Entrainer project. Elisa Peñalvo from the Polytechnical University of Valencia will explain us which have been the most relevant activities they have carried out in Entrainer project. And the second one will be Antonius Schroeder from Technical University of Dortmund. He will explain us about skills for energy intensive industries project. Elisa, you can go on.
Thank you, Anna. First of all, thank you for this kind invitation. For us, it's really a pleasure to share with you and with all the participants the results of our project in Trainer. And not just that, but to understand what other projects are doing is, to be honest, and all the initiatives are very, very impressive. So congratulations on these achievements. So I'm going to start with the presentation from our project. Let me see. Can you all see it?
Yes, no. We can see your screen. And please remember, we are a bit with behind. Some delay. Yes, so please
I will go
try
just to the highlights
with your 10 minutes. Thank you.
Of course. So we are a university. We are part of the Advanced Solutions for Energy Sustainability research group that is part of the Universidad Politécnica de Valencia, located in Valencia, Spain. And the project that I'm presenting today is Entrainer. Entrainer was a 3-year project that was funded under the LIFE program, and it was based on developing a new methodology for energy transition audits that will include or support the enhancement of the decarbonization and action plans. That was the main core. The participant countries included Greece, Romania, Italy, and Spain, the Mediterranean arch. So within the project, we developed this methodology that I will explain a little bit later on the main content, and we tried to validate the methodology in different different sectors, industrial sectors, with energy intensive qualifications or energy intensive characteristics, and in order to understand if this could be a viable alternative in order to promote not just the energy audits but also the decarbonization of the industries. With all this, the main concepts associated with the project included, as I mentioned, the energy transition audit development. There was an enhanced typical energy audit focusing on the decarbonization and the non-energy benefits associated to what does it mean if you reduce a kilowatt hour, what does it mean in other processes within the manufacturing enterprise or company. We delivered the energy scans. That was the initial stage prior to the energy transition audits, the decarbonization action plan, and at the end, we created this very strong training program with accredited credits or accredited programs in the 2 stages. So as a general number, so you may have an idea what we have done, because we finished last December. We have achieved 8 different editions of the accredited training courses, training around 880 people. We have reached 80 different industries where we carry out the energy scans. Out of those 80, we selected only half of them that will be or were selected for the preparation of the energy transition audits, and including the use of the innovative tools that we have developed within the project, and you have them available on the website. Everything was included in a platform, the training platform, that of course included as well the training activities. So what does it mean, energy transition audits? We wanted to connect the management together with the final certification, but with the selection of the main or most promising strategies in energy efficiency. So we connected with the management, we created the decarbonization group, and from then we carry out the first energy scans of the different companies. From that, we can tell them what is the potential for energy efficiency in savings. And if it was, in this case, since we have to select only half of them, if they have major potentials, then we will move to the next steps to identify or to study in details what will be the specific associated savings. With that, then we have a list of different strategies to be developed or to be implemented for the reduction of energy consumption or the substitution for renewable energy sources. We kind of rank all these possibilities into a decarbonization action plan that is also discussed with the different actors within the company, management, technical, and implementation technicians that will be implementing and monitoring the results of the implementation of those energy efficiency measures. With all that, we create this decarbonization action plan, and we move to the certification so the company can receive a benefit associated, like our previous colleague was explaining, associated to the weight certificates or any other certification that might be available. So the main one of the focus of our project, besides developing this new methodology, was to make sure that all the different actors were involved in the preparation of this decarbonization plan. So we included the energy auditors, the management, and the energy managers, in-house and out-house. Let's say, for example, if you have an external auditor, energy auditor that is collaborating with management in order to make sure that they decide what will be more strategic for them, but also from the energy manager in-house to make sure that this can be implemented. So far, we have standardized like an inventory of 327 kilotons of CO2 as a baseline in the 20 sites. We have identify or we work with heavy industries in order to make sure that we were able to test and validate this methodology, and we base the preparation of the decarbonization plan, as is mentioned here, based on the different scopes and based also on the cost-benefit analysis in order to define at the end a roadmap according to the funding possibilities. We have here the main results that we achieve in terms of the primary energy savings, final energy, renewable integration that we propose, the reduction of greenhouse emissions, and the investments that the different companies, those 40 companies, will have to invest in order to achieve this savings. The main feelings around the different sectors is that the energy transition audits was very interesting. It was a lot of interest from the different companies when we explained the new concept, especially because they were really interested in the last part in order to include a decarbonization roadmap that will allow them to have a specific pathway in order to achieve a specific target, such as, for example, 60% of reduction by 2030 or 50%, since they have to compile with many different European regulations or recommendations, such as like the Fit for 55 or the Repower Europe. So here I have an example, but it's very similar to in terms of the energy efficiency measures that we propose, like our colleagues mentioned it before. So I'm not going to go in detail. I'm just going to highlight what has been different from the typical energy audit. And it's exactly what you have here is the evolution of the decarbonization target and when you have to implement the different measures or the different strategies in order to achieve to the target by, for example, in this case, 2050, and what will be the investment that you need in order to achieve it. So here you have, for example, some of the examples of measures that have been mentioned in the previous presentation, such as like the heat pumps, electrical vehicles, the variable speed drives, etc., and of course the implementation of the renewables. But as you can see in the slides right now, our methodology or protocol in order to implement it was first to reduce as much as possible the energy consumption and then implement the renewable sources, distributed energy resources. Some conclusions, then we have created the emission inventory as well, and we have identified 89% of total emissions, mainly due to natural gas, as it was expected and mentioned here during this webinar. We have approached it with a lot of interest the decarbonization action plan, the electrification challenges that we're going to encounter in the future since we are electrifying more and more what it will be the demand. And this is something that is still under study, and how we are going to respond to these electrification challenges introducing the renewable energy sources. From the technical challenges, we have is associated with what I just mentioned, is the installation of photovoltaic creates grid bottlenecks among other problems within the grid. It is true that it's recommended to include storage with the photovoltaic, but this, in terms of the investment, the financial indicators are less convenient or less promising. So we have identified, or we have come to the conclusion that the full switching from natural gas, for example, or electrification doesn't have a clear policy or regulative environment. So it's kind of difficult to trying to bring all the pieces together. So we understand that the local regulation, especially with the PV installation in different parts of the countries that we have worked on, is something that needs to be further studied. Another thing associated with the project was the non-energy benefits, and we have identified also several barriers, such as, like I mentioned, the lack of standardized methodologies or the difficulty collecting accurate data, because you need to relate, for example, time reduced in the manufacturing process, or the benefits for the people working on a specific manufacturing line associated to the energy reduction. So you need to make sure that you carefully understand both processes in order to do the relation among them. And regarding the cultural barriers, we have also identified that the companies often view energy savings such as technical and cost saving, but not focusing on the long run periods, like it will be, for example, the decarbonization plan. And I think this is why it was very interesting for them to introduce this new approach. The employees obviously like awareness and engagement, so this is something that needs to be worked on in order to make sure that all the different parts of the company participate in the development of these activities. And this is where we have identified the resistance to change, etc., in terms of the cultural barriers. So it's very important that you empower people in order to participate in the process from the beginning. This is why we have created the training courses, as I mentioned in the beginning, that it was the third part. One, it was for energy auditors, the current ones that are already working in the traditional energy audits, but we also focus on the future energy auditors or future energy professionals in order to make sure that this methodology was understood. And at the end, we have reached approximately 1,000 trainees within the projects that were accredited. This I mentioned is very important in the energy transition implementation, to have the roadmap as a strategic tool and to identify the fundings based on your interest. That was our main lesson learned, that in added value that we could see that the companies have interest in. And the next step, even though we have finished we have identified that this is also moving, and there is is a work line that is going to be continuing in the future, since this is very important. The training and upskilling of the different professionals is important, and to have in order to achieve the decarbonization of the future, we need to implement these kind of approaches. So three parts are very differentiated. One is introducing what will be this type of methodology that is wider than it was the traditional one. The second pillar will be to approach the local regulatory and that is aligned with the European objectives, etc. So everyone goes in the same direction. And of course, the training, in order to make sure that all the different parts of the process understood what is the importance and what they're doing, and they really know what is the methodology as it is. So this is it from my side. I hope I was on time, Anna. I tried to be as much as possible.
Thank you, Elisa. Yes.
Because reducing the project in 10 minutes is quite...
It's very difficult. Yes, we know. Yes, we know.
But I appreciate.
But if someone needs more clarification, they will have your contacts to ask what they want. Okay, and to finish the presentation of this morning, we leave the floor to Antonius. He will explain us about the Skills for Energy-Intensive Industries project. Antonio?
Yes, thanks a lot for inviting me, and it fits very good to the presentation before from Elisa. May I share my screen?
Elisa, could you stop sharing your screen, please? No.
Done.
It's fine.
Okay.
Now we can see your screen.
Yeah. Okay. Yes. As I said, my name is Antonio Schröder from TU Dortmund University, and I'm the coordinator of this Skills Alliance for Energy-Intensive Industries, which is a very, let's say, important step in the direction of sustainable establishing the proactive adjustment of the workforce. I'm also the coordinator. Let's start a bit with the problem. Sorry. Energy-intensive industries are not only in a green and digital transformation, it's also a social transformation. And that's very important to have this in mind. I listed a few topics there: aging workforce, attracting talents, and so on. So this triple transition has always to be in mind to enhance efficiency, sustainability, and also workforce resilience in a more long-term perspective of competitiveness. This Skills Alliance for Energy-Intensive Industries is part of the Pact for Skills of the European Union. There are different industrial ecosystems and partnerships placed. So you see here construction, mobility, renewable, aerospace, and defense. But we are focusing on the energy-intensive industries also with this Pact for Skills, which is, let's say, the foundation for our Skills Alliance. We do not start from scratch, because we already had two Skills Alliances beforehand. One for the European steel industry, ESSA, and one cross-sectoral, the energy-intensive industries, focusing on industrial symbiosis and energy-intensive industries. You can find more information here at the homepage of the European Commission. What is the partnership? We have 33 partners from 9 member states and Turkey, focusing very much on labor market actors, including companies, intermediary organizations, but also higher education and vocational education and training providers, consultancies, and also a civil society organization, so that we have also this perspective on board. This is how we are working. So we started with the skills intelligence tool. I come back to this a bit later to analyze the technological needs, the skills demands, and also the focus on Industry 5.0 concept, which is putting human centricity in the center of developments. Against this backdrop, we developed cross-sectoral trainings, elements, collected also training elements. You see here a few things mentioned: digitalization, artificial intelligence, image and recruiting, but also energy and resource efficiency, and train the trainer. Lessons learned from the former skills alliances was to have a much deeper dive into the sector specificities concerning trainings and their framework. So that's also a very important part of our work program. Then another lesson learned was to focus much more on the national regional integration and marketing. So we are working on this. I have to say that we are now in the second of 4 years. So, but in the last period of the project, and we already started, this will be in focus. And I will tell you something about our online training platform, Hub 5.0, concerning learning solutions, micro-credentials, etc. So, but let's get a step back in the direction of the skills demands. When we analyzed the job profiles of the 10 sectors we are engaged in, so it's steel, ceramics, water, engineering, minerals, and so on. We found out that there are some cross-sectoral generic job profiles for industrial symbiosis and energy efficiency. And this is not so much dedicated, the job profiles, to the production area, but a lot of functional areas of the companies are affected by industrial symbiosis and energy efficiencies. You see here materials, products manager, energy manager, environmental, waste manager, etc., up to quality managers. So that's the management level, and we found also out that it's not only a task responsibility of the management level, but we have also to include the operational level. So operators and foremen related to the different functional and production areas are also to be integrated. And we thought concerning industrial symbiosis that there is a need for an industrial symbiosis facilitator outside the companies who has, let's say, the trust of the different companies and so on. And then there was already developed a training from the Inside project for this profile. And then we looked at what kind of skills are relevant, and you see here for the management and operator level, there are technological skills relevant concerning industrial symbiosis and energy efficiency, but also individual, personal soft skills or transversal skills. So collaboration, entrepreneurship, complementary thinking, and creativity, we found out. Concerning the management, only for management, the main tasks are regulatory and business-related skills listed here in the slide. But now to our assets we found out we developed in the skills for EII roadmap concerning the core components of our ecosystems. There is a foresight tool which is called Skills Foresight. So where we can, this is AI based, where we can detect emerging skills trends continuously. With this, we collected 2,200 relevant skills in our database and more than 500 cross-sectoral and sectoral skills and trainings. So, and the second asset is the Hub 5.0. That's the online training platform, which we see also as a GPS for careers in industrial transition. And I will tell something about it in a later slide. So, but these both elements, we aim to form with it a self-updating system, which is also moving forward after the project funding period. So Hub 5.0, this is a short video showing what we are doing. So if you want to have a look to play around with this, you see here already that's a capability assessment going on. So looking for which kind of skills you have and which kind of skills you need. And then you are directed to occupations like the green steel architect. So it's based on learning outcomes, and it's very, very much practical driven, and it's used already a lot. We see this as an ecosystem, which means that this training platform could be used, but also this training platform could be a platform to distribute trainings. Maybe Elisa, for your project, after the project time, it might be also interesting to integrate it in this infrastructure, because we are not only focusing on one sector, but more and more using this infrastructure for other sectors as well. So it's associations are there, industry is companies, university, high schools, training providers, but also governments and international organizations, as well as equipment and service provider. As I said, we have a skill directory. Main thing is a capability assessor, where you can identify individually your learning gaps related to specific occupations. You will be directed to a learning solution directory, and we are working also on micro credentials, which are blockchain based. Yes, the impact, and then I will finish very quickly, is showing that we are now in 2025, we have more than 20,000 learners. We have more than 1,000 trainings available, and these trainings are in different languages. So we are working on this as well, and we also have a feedback benchmark system where we could show which trainings are most positively rated by the learners. And if you need more information about this, please contact my colleague Jorge Murat from the Steel University and World Steel, and he is taking care of the platform and the integration of other interesting people. So, and here are some links where you can get more information, and I'm really open if you want more information or interested in joining, for instance, the Hub 5.0 platform. So thanks a lot. That's all from my side. Hopefully not
Thank
too
you.
long.
Thank you very much, Antonius, for this vision, for this general vision of your project. And now we are going to finish our webinar with an interactive quiz. My colleague Javier will take the control of the screen and will show us a link to join the platform and to answer the questions, okay? It's a very quick quiz.
Thank you, Anna. I'm going to share my screen again. Can you see my screen? Yes. Okay. Well, this is a Menti quick questionnaire. So I would like to invite to all of you to join this questionnaire. So I will give 1 minute, 2 minutes, and because and I would like to know your opinion regarding energy efficiency. So please get your phones and scan this QR code and see if we can get your opinion, because your feedback regarding energy efficiency is really important, as all of you know about energy intensive companies. Okay, we have 13 people right now, so let's wait a little bit just in case someone is still trying to access. This is a set of questions of about 8-10 questions, and I just need to know your opinion on these questions. So, okay, we are 15 for the moment, so let's start with it. Okay, this is a tip or a text that I put here. That if you are not an energy intensive industry, please answer the following questions based on your experience working with energy intensive companies, because not probably all of you are working on an energy intensive company, but in a different sector or type of company. Okay. First question, energy maturity level. How would you describe the organization's energy management level? No clear strategy, occasional energy audits, a structured energy efficiency plan, or advanced energy management with continuous monitoring? Okay, we've got 8 answers for the moment. Well, your feedback on this is really important, because we can use this information later on our project to work accordingly to your answers on this. Okay, 12 answers for the moment. Okay, we'll wait 10-15 seconds more for the 4 people left. Okay, no answer for the moment for the 4 people for missing. Okay, next question. Energy management. How important is the role of the energy manager in the companies or in your company? No energy manager, limited responsibilities, play an important role, or strong influence on strategic decisions? Last question, 13 people replied. Now we have 12, so we are waiting for the last one. No answer. Okay. Okay, next question then. Practice versus theory. What do you actually do with the results of an energy audit? They remain as a report. We implement some measures. We implement most measures, and continuous follow-up and improvement. Okay, now we have more people replying. That's good. So the most of you reply that we implement some measures. Okay. Next question then. Which type of measures do you implement most frequently? Low cost or no investment measures, operational improvements, equipment investments, or renewable energy solutions? Okay, let's give 10 seconds for the last person to reply. Okay. Next question then. What's your biggest barrier to implementing energy efficiency measures? Initial investment, lack of time, lack of internal support, uncertainty about return on investment, or lack of knowledge? Okay, it seems that most of you are replying uncertainty about return on investment. Okay, 15 answers. So let's move to the next question. Which stage of the energy audit process is more challenging from your point of view? Data collection, technical analysis, prioritization of measures, implementation, or monitoring and follow-up? Okay. It seems that data collection is the most chosen option. Okay. Next one. How do you manage your energy data? It's not collected with Excel sheets, basic systems, or with advanced platforms. Okay. With manual Excel sheets seems the most popular. What do you need to use? What do you need to improve your use of data? Tools, training, time, data quality, or it's not a priority? Okay. Let's move to the next one. What would bring you the most value from initiatives like Life Audit Plus project? Improve audit methodologies, real case studies, practical tools, training, or access to funding? Okay. Next one, in one word, what is the most, this is, you have to reply writing the answer here. So in one word, what is the most challenging aspect of achieving energy efficiency? Okay. It seems the data and data collection is the most popular. Okay, one more because we are 14. Okay. Let's move now to the last question. This is an open question. What do you need to implement more energy efficiency measures? Let's give 1 minute or so for you to reply this question. Okay. Okay. So this was the last question I had for you. As I said at the beginning of the questionnaire, thank you for your participation because your input and collaboration are greatly appreciated and will be very valuable for our project, for Life Audit Plus project, and we will work with these answers accordingly to your answers to this questionnaire. And yeah, that's all from my side. Anna, I don't know if we have any questions today for.
Well, in the chat there is not a question. No one has a question, but if you're revising the presentations or the slides, do you have any question? Please, you can reach us by email and we will answer it. And that's all for today. I think it has been an intense morning, very fruitful. And I just want to remind you that the webinar has been recorded and will be available on the website of the project and in our social net account. And you will have the opportunity to revise in more detail the slides and the presentations that has been delivered this morning.
Anna, sorry, one last thing. We had one person in the chat with a raised hand. It was Adrian. I don't know if he has any question for any of the speakers. So, Adrian, you can now talk if you have any question. Okay, yeah, he said that, don't worry, I clicked by accident. No problem. Then I think that was all.
Okay, so thank you very much. It seems that everything is clear. It seems that everything is clear for all of us. So thank you very much for participating and for joining us today, and keep in contact. Have a nice day.
Thank you.
Thanks,
Thank
everyone.
you.
Bye bye.
Thank you.
Thank you.
Bye bye.